Okay, so the question says, solve the system of equations using the elimination method. And the first thing that I notice here about these two equations is that my y's don't line up, my equal signs don't line up. So I'm going to need to take care of that first before I do anything else. So before I start using my elimination method, what I'm going to do is take that first equation and I'm going to rewrite it to be 5x, and I'm going to add 2y to both sides to cancel it out there, so it's going to be plus 2y equals 9. Okay, so forget about this one because it wasn't in the right form. So starting over now, notice my x's line up, my y's line up, the equal signs line up, my constant numbers line up, and now I'm good to go. If I were to add those two equations, nothing would cancel out. If I was going to add the x's together here, I would get 7x. If I was going to add the y's together, I would get 5y. So I'm going to need to do something to these equations so that one of the variables cancel out. So that's always my goal. My goal is always that one of my equations cancels out. Okay? So looking at these two, I have a choice. I can do anything I want, kind of, but I want to make sure that either the x's or the y's cancel out. So if I look at my x's, just because they're first, I'm thinking if I made them both 10, or one of them positive 10 and one of them negative 10, then they would cancel. And I can do that by multiplying the first equation by negative 5, and if I multiply the second equation by positive 2, I'm going to get one of them negative 10x, one of them positive 10x, and it's going to cancel out for me. So let's do that. Remembering that it's an equation, so I need to make sure that I do the same thing to every term. So that's going to give me negative 10x plus negative 15y equals positive 15. And then if I multiply that second equation by 2, I'm going to get positive 10x here, and then positive 4y, and then positive 18. Okay, so what I wanted to happen did. I wanted to, when I add these two equations, for my x's to cancel out, and they do. And now I'm going to add negative 15y plus 4y, and I'm going to get negative 11y. And I'm going to add 15 and 18, and that's going to be 33. And this does work out kind of nice for me. If I divide both sides by negative 11, we get y equals negative 3. Okay, so now I think that I'm done. A lot of people think that they're done, but you had two equations, you had two different variables. Right now, I only have one of them. I only have y. So I need to go back, and I'm going to erase a bunch of stuff here. I need to go back, and I need to plug in negative 3 for y in one of my equations so that I can solve it for x. So I'm just going to go back to my original equations, erase all that stuff that I did so we have room. And back into my original equation. Doesn't matter which one. I'm going to choose the first one just because I like it. And instead of y, I'm going to put negative 3. So that's going to become 5x equals negative 2 times negative 3 plus 9. 5x equals 6 plus 9. 5x equals 15. And now to divide by 5, I'm going to get x equals 3. So I'm hoping that's my answer, but to double check, I'm going to plug it into the second equation. I'm going to substitute 3 in for x, and I'm going to substitute negative 3 in for y and see if it works out. So I'm not sure. When I do that, let's erase some of the stuff again. That's going to give me 6 plus negative 9, and I'm not sure if that's negative 3, and actually it is, so I am right. There's my two answers.